Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई के रखिथिबी तमे सर्च करि परिबो ओके थैंक यू
हेलो स्टूडेंट्स आज टॉपिक रे आमे डिफ्रैक्शन ऑफ लाइट विषय रे पढ़िबा और डिफ्रैक्शन होची वन ऑफ द प्रॉपर्टी ऑफ लाइट वेव्स और याकू आमे बुझी परिबा as the bending of light around the corners of an obstacle. So whenever you place an opaque obstacle in the path of light ताले आमे गोटे sharp shadow पाइबा से object रो in the screen. Similarly, if we place a slit in the path of light, then only a portion of the screen will be illuminated. So this happens only when the size of the slit or obstacle is large. Okay, बड़ size रो जेतले हेतबो, but if we decrease its size, okay, if the obstacle or the slit is made small ताले size decrease हो गला, then some light will enter in the geometrical shadow of the obstacle or slit, and this phenomenon of bending of light जेमति कहली around the corners of the obstacle or slit and entering of light into the geometrical shadow region is called diffraction. Okay, so the light waves are diffracted only when the size of the obstacle or slit is comparable to the wavelength of the light. Okay, so there are two types of diffraction. The first one is the Fresnel diffraction and the second one is the Fraunhofer diffraction. Okay, Fresnel diffraction it is a type of diffraction which takes place at a slit when the source of light lies at a finite distance from it. Okay, pakhre thibo finite distance re. But however, Fraunhofer diffraction case re, here you have to place the slit when the source is at a infinite distance from it. Okay, Fresnel re finite distance, Fraunhofer re infinite distance, and following are the main points or features of Fraunhofer diffraction. First हमें Fraunhofer diffraction या विषय रे आकु पढ़िबा. Okay, so first point, both the source and screen are at infinite distance from the slit or obstacle जेमति कहला. Then number 2, the wavefront of the incident light which is incident on the aperture or slit will be a plane wave. Okay, planar wave front आसीबो. Okay, जेहेतु infinite distance रे अछि याको हमें detail आकु बुझिबा मध्य. Okay, then third point, the diffracted light is collected by a lens. Okay, गोटे lens use करिकि हमें diffracted light को collect करिबा. Then fourth point, there are large number of parallel rays falling on the lens corresponding to each point on the screen, and then the diffraction pattern is always bright. Okay, then last point, mathematical investigations are easy in case of this Fraunhofer diffraction. So ये जो diffraction of light विषय रे, this I have taken from one book जो थे कि बहुत ही briefly या विषय रे दीजिए. Now this I have taken from another book about the diffraction. So already जेमते कहली, here you can see याकू ये figure रे मध्य बुझेइछि diffraction को देखो एठी हमें गोटे source नेबा, source of light. Okay, S which is emitting light in all directions. Suppose हमें एठी L नै गला गोटे होछि एटा screen which is placed as some distance from the source. Now let us place an opaque obstacle. Okay, AB, right? So this obstacle is placed between the source and the screen. Okay, now according to the geometrical consideration, light जेतेबेले या ऊपर पडुची ए बी ऊपर आमे जानिचु न्यूटन्स जो corpuscular theory कहूची light travels in a straight line. तेणु करी आमे जदि एठी स्ट्रेट लाइन ड्रॉ करिबा फ्रॉम द सोर्स S to A and extend it, suppose A dash रे एटा स्क्रीन को टच कला. Similarly from source S to B and extend it, suppose B dash point रे स्क्रीन को टच कला. ताले geometrical consideration हिसाब रे we must have light above this point A dash and below this point B dash. But however A dash और B dash मझी रे किछि भी लाइट रहिबा कथा नुह एज पर न्यूटन्स कॉर्पस्कुलर थ्योरी जोटा कहूँ लाइट ट्रावेल्स इन ए स्ट्रेट लाइन. किंतु एक्सपेरिमेंटल ऑब्जर्वेशन रु देखा गला जे कोन ना ए जो ए डैश और बी डैश मझी रे किछि लाइट रही जाउछि. ओके, देयर इज सम लाइट जस्ट बिलो ए डैश एंड जस्ट अबव बी डैश. ओके, जोटा कि कंट्राडिक्ट कला एबे न्यूटन्स कॉर्पस्कुलर थ्योरी को. ओके, सो ए जो एक्सपेरिमेंटल ऑब्जर्वेशन देखा गला याकू एक्सप्लेन करबा पई हेले we have to assume that light departs from its normal behavior माने traveling in a straight line and it enters into the shadow region जहाँ द्वारा से जो obstacle हमें देखिबा को पाउछु it will have a shadow having the edges not sharp. Okay, the edges of that shadow will not be sharp. Okay, अच्छा याको आउ टिके भलसे बुझिबा डिफ्राक्शन ऑफ लाइट. ओके, सो देखो सेम टाइप ऑफ बिहेवियर आमे साउंड वेव्स रे बहुत भल भाव रे देखिया को पाइबा. ओके, फॉर एग्जांपल कंसीडर जे गोटे लोक अछि एई जगह रे. ओके, एठी गोटे लोक अछि, देन देयर इज ए वॉल, गोटे कांथ अछि. ओके, देन एई जगह रे आउ जणे अछि. ओके, so sound wave, suppose a lokota sound wave create kala party kala, then this fellow, suppose this is person A, this is person B, then person B can easily hear the sound created by person A and vice versa. Jodio mojire kantha achi, that means we can say here because kantha mojiru deiki to sound travel kari paribani, that means sound wave must have traveled like this, bend he jaichi. Okay, so इटा भी होउची गोटे डिफ्रैक्शन रो एग्जांपल साउंड वेव्स रे एंड इट इज मोर प्रोमिनेंट. ओके, रादर देन योर इन केस ऑफ लाइट केस रे डिफ्रैक्शन टा एते प्रोमिनेंट नो, साउंड रे हाईली प्रोमिनेंट. ओके, सो ए जिनस एठी कहूची सेम टाइप ऑफ बिहेवियर इज शोन बाय द साउंड वेव्स. ओके, सो जेमते कहली दुई जण छिडा आइचंती. ओके, रूम रे हैविंग अ वुडन पार्टीशन इन बिटवीन देम. ओके, so height रखिदबा से partition रो less than the height of the ceiling. Okay, then the two persons can easily hear each other. So this indicates that sound from one person reaches the other after bending around the corners of that partition. Okay, and bending in case of this sound is much larger, जेमती कहली much prominent as compared to that of your light, and this is due to the difference in their wavelengths. Okay, because sound waves is having a wavelength nearly 10 to the power 7 times as compared to that of your light. So this phenomenon of bending of light around the corners and spreading of light waves into the geometrical shadow of the object is called diffraction. This is the definition of diffraction. Okay, so an explanation to the phenomenon of diffraction can be given on the basis of Huygens wave theory with a special treatment of wavefront as suggested by Fresnel. Okay, so classification diffraction रो already हमें स्टार्टिंग रे देखुतला, याको आउ टिके डिटेल वे रे एठी एक्सप्लेन करछि. गोटे हला फ्रेनेल डिफ्रैक्शन जो थरे कि हमें देखुतला जे सोर्स आउ स्क्रीन फाइनाइट डिस्टेंस रे अछि फ्रॉम द ऑब्स्टेकल. ओके, एंड हियर द wave front is spherical or cylindrical. You can see here it is spherical. Okay, the source is producing spherical wavefront, obstacle dekhi gala, tapre screen out ku gala. Okay, so here also it is spherical, right? The second one is Fraunhofer diffraction. Now here the source and or screen, okay, are effectively situated at infinity. किंतु इन्फिनिटी रे आमे अच्छी बोली केमती क्रिएट करिबा. ओके, वी हैव टू मेक इट appear to be situated at infinity by using convex lens L1 and L2. Okay, and these two lenses are placed at a distance equal to their focal lengths from the source and from the screen, right? So आमे जानिछु focal length रे जदि object अछि lens रू ताले convex lens ପାଇଁ it will create the image at infinity. So it is जो spherical বা cylindrical wave आस्तुला after refraction through this lens it will become planar, and here also it will also become planar. That means we have made the source and the screen to be situated at infinity from the obstacle by using these two lenses L1 and L2. Okay, now the second thing is that I am almost all the optical instruments involve the use of lenses or mirrors which change the curvature of the wavefronts. ତେଣୁକରି ଏଇ जो Frown over diffraction ର significant importance ରହିଛି. Okay, now let us proceed further. ଏବେ ଦେଖିବା explanation to the phenomenon of diffraction. देखो different scientists have given different types of explanation ए जो diffraction को बुझेवा पाई. Okay, so earlier explanation केतरा जदि देखिबा, first one was given by the great scientist Isaac Newton. So से a diffraction phenomenon को explain करिले by using the basis of corpuscular theory, according to which corpuscles will experience repulsive forces. केतेବେଳେ repulsive forces आसीबो? While they are crossing an opaque obstacle. Okay, এই explanation देले, but however variety of diffraction patterns shown by different obstacles could not be explained by this theory. Okay, so এটা fail ହେଲା. तापरे second explanation आसिला Huygens attempt. So he tried to explain the basis of his principle which is called Huygens principle. So say कहले जे secondary waves which are starting from different points of primary wavefront could spread into the shadow region. But again यारो भी contradiction आसिला because of the formation of dark and bright bands, and their position and width could not be explained by this Huygens theory. Okay, तापरे third attempt आसिला Young's. Okay, Young's double slit experiment तमे देखिथिबो. Okay, so से explain कले ये diffraction को by saying that it is actually caused due to the interference between the direct light and the light which is reflected from the edge of the obstacle, and it is reflected at a grazing angle of incidence. Okay, so it is experimentally confirmed that the nature of diffraction is independent of the fact whether the edge is sharp or round. So again एथिरे भी contradiction आसिला. This cannot be explained on the basis of Young's argument. Finally यारो ठीक explanation देइथिले Fresnel. Okay, so Fresnel was able to explain the phenomenon of diffraction by making a blend or combining the Huygens principle and the phenomenon of interference. So say यारो postulate देले जे diffraction was due to interference between the waves starting from different parts of same wavefront. Okay, so এই explanation ପାଇଁ से किछिटा assumptions रखिले. Number 1, every element of a wavefront sends secondary waves continuously and not a single spherical wave as predicted by Huygens theory. Then second point, to consider the effect of wavefront at any point on a screen which is situated away from it, the wavefront should be divided into very small parts jaku kuagala Fresnel's zone boliki. Okay, या विषय रे हमें पढ़िबा को डिटेल. Right, so resultant effect at that point will be due to the contribution coming from all these Fresnel zones. Okay, then the third point, the net intensity jodi dekhiba at any point due to a single zone depends upon the distance of that zone from that point. Similarly, net intensity at any point due to the whole wavefront depends upon the relative phases of different zones. अच्छा, तापरे नेट इंटेंसिटी एट एनी पॉइंट डिपेंड अपन गोटे फैक्टर उपरे या डिपेंड करे जाकू कहू आमे ऑब्लिक्विटी फैक्टर. ऑब्लिक्विटी फैक्टर माने कोन? इट इज डिपेंडिंग अपॉन द एंगल व्हिच द लाइन जॉइनिंग दैट पॉइंट with the zone makes with the normal to that zone. Okay, so याको आमे फिगर रे बुझिबा. Okay, here you can see S is the source of light. We have taken a zone a very small zone C. This is the wavefront, right? And we have taken C to be a very small zone, right? And here A B এটা ଆସିଗଲା suppose ଗୋଟେ slit obstacle जोटा, okay? So এই जो zone को normal ହେଇଛି CO, এটা ଅଛି screen ଟା, right? So এটা normal ଟା ଆସିଲା CO. Now जो एंगल क्रिएट होची एठी देखो CP जेतेबेले हमें आसुचु डिफ्रैक्शन हेकी आसिला, दिस एंगल थीटा इज द एंगल और obliquity factor. Okay, so if we calculate the effect of this small zone C at this point P, which is the point of observation, then it will be proportional to 1 plus cos theta. Okay, ताले एबे यारो किछिटा कंडीशन आमे देखिबा जदि एट पॉइंट O आमे कंसीडर करूछु हियर थीटा विल बी इक्वल टू 0. Okay, then cos theta will be equal to 1. That means 1 plus cos theta will become 1 plus 1 equal to 2. Okay, which is the maximum value, right? Cos theta is maximum value because 1. Therefore the intensity at this point O due to the zone small zone C will be maximum. So as the value of theta increases as we approach from the point O towards the point P, then there will be increase in the obliquity factor. Okay, and hence the intensity at P will be lesser. Okay, intensity decrease करिबो. Okay, so याकू आमे simple example रे भी बुझी परिबा. Suppose एई जगह रे आमे गोटे torch light रखिछु. Okay, तमे देखिथबो torch light रू जो light टा बाहरिबो तारो जदि आमे normal incidence देखिबा, it will be having maximum intensity. But however जो bending है कि एई भलिया light बाहरुची याथु, okay, it will be having less intensity, right? So आ गुटे जदि आमे केस कंसीडर करिबा, सपोज आमे ठीक उल्टा डायरेक्शन रे C रु S टुवर्ड्स द सोर्स एबे कंसीडर करला, ताले एंगल थीटा एबे केते हिजबो? ओके, नॉर्मल सहित ए जो एंगल क्रिएट हबो इट विल बी 180 डिग्री, राइट? ताले cos थीटा रो वैल्यू हेगला -1, ताले एठी 1 प्लस -1 और it will become equal to 0. That means the effect of this small zone C in the backward direction will be equal to 0, or in other words there is no backward wavefront. Okay, wavefront cannot travel in the backward direction, right? So this is all about the diffraction of light.
Thank you.